Daniel Ehrenreich. É um prazer receber você dentro do Cybersecurity Summit. Hoje ele vai estar falando sobre treinamentos e funções da parte de escada. Como é importante ter uma abordagem e uma abordagem coordenada para essa cibersegurança dentro do aspecto industrial. Obrigado, Daniel. É com você.
Thank you, Rafael, for inviting me to this conference in Brazil, Cybersecurity Summit Brazil 2020. My presentation is going to focus on a coordinated approach towards industrial control systems, OT, cybersecurity. My name is Daniel Ehrenreich, and I'm in the industrial activity over 44 years, dealing with many aspects of product development and the SCADA systems. And in the past 5 years, I'm a consultant for industrial control cyber security. I do training and consulting, lecturing, and I'm glad to be here at this conference. When we speak about industrial control applications, we are actually looking at several vertical applications. We talk about electricity, water and sewage, oil and gas, chemicals, food and beverage manufacturing, and also building an energy management system, which is quite a new area that we are dealing. We are not talking about home and residence, but we talk about big government building and industrial building, which must be protected. We are talking about controlling communication networks, cellular communication, citywide Wi-Fi communication, and of course, manufacturing, I already mentioned, public safety, sirens. And recently, we see the introduction of smart cities. So all these systems are using very similar industrial control systems. We call it OT, and we recently talk about IIoT. I will talk about it later, and will explain all the details. When we speak about the architecture and organization architecture, you can see on the left side, you see two firewalls, the orange ones. On the left side, you see the industrial control system. In the center, you see the IT operations, the company IT operation, and which is connected to the internet. So we see that although not directly, but indirectly, through firewalls, if we are not doing a very careful and correct design, then attackers remotely may penetrate to the industrial control part, and I will explain what can be done. Typically, when attack is happening on such a systems, we can talk about the operation outage. We can talk about damage. In worst case, we can talk about people who may get hurt if something happened, because industrial control may involve large pumps, large turbines, and many different products. Why we see the risk that we are worried about? There is a huge difference between IT operations and industrial control operation. A huge difference. While IT computers are being frequently updated and modernized, industrial control systems use legacy hardware and software. The configuration is not always carefully done from a cybersecurity point of view. In many legacy systems, we don't see encryption between remote sites and industrial control centers. Then we have the remote access, especially in these days when people, because of the big epidemic problem, people cannot come to work, or maintenance people cannot repair the systems. They are required to do remote access, and remote access is another threat that needs to be taken into consideration. I already showed this picture, and now you can see the real picture. On the right side, you see the attacker who can connect through the internet, through the IT operation, compromise the firewall at the entrance to the IT, compromise the firewall between the IT operation and the industrial operation, and finally the goal of the attacker is to reach the specific RTU or PLC or DCS system which is controlling the turbine or which is controlling the power plant, and this is the goal of the attacker, to reach that specific PLC. So we already know what is a threat, and later we will talk about how systems can be protected. When we are talking about the risks, actually we need to look at three main vectors. There are many ways to attack the systems. We need to talk about the internally generated cyber attack, which can be started by an employee, can be started by the service person or somebody who's penetrating to your facility. It is exactly what happened in 2010 when we remember the Stuxnet attack. It was an internally generated cyber attack. It was not done through the internet because the plant was disconnected from the internet. Then we are talking about the externally generated cyber attack. Externally generated cyber attack, it's the typical attack exactly as we've seen on the picture before. Attacker is connecting to the internet, he is compromising the firewall, gaining access to the IT section. In the IT section, he can determine who is the administrator, who have specific privileges. He will learn, if he's an expert, he will learn how to compromise the firewall, and then we will enter to the industrial control zone. Very important to remember that attackers can be present in your IT operation anywhere between 100 to 200 days before they are detected. So imagine attacker is penetrating to the IT operation, and he can learn many things during such a long time. So this is a very high risk and needs to be taken into consideration. And this is one of the reasons why a good collaboration between the IT cybersecurity team and the industrial cybersecurity team are so important. Finally, I want to talk about the supply chain cyber attack. This is a new vector we didn't consider in the past, but we need to look at the vendors. Where are you buying the computers? Where are you buying the software? Who is performing a service to your computers, to your industrial control system? How about if some of your employees are downloading a free software? And we call it supply chain attack because this is really a serious problem, that you are buying a computer or buying a PLC or replacing a PLC, and it's already equipped with a malware. A major problem. I want to talk about the very famous term 0 day. Usually we say 0 day, and everybody knows that 0 day is something that we didn't see before. But I would like to explain to the participants at this presentation this term a little bit more details. We have the 0 day vulnerability. It is a vulnerability which was not detected before. We don't know how to, we were not prepared to protect ourselves, but it's already existing. There is a vulnerability. Nobody knows about it. Finally, second, we have the 0 day exploit. where the attacker is already exploiting the vulnerability. He already knows where are the weaknesses, where are the problems, how to penetrate to the system, and he's taking actions to penetrate your system. And finally, we have the zero-day attack. So we have 3 steps in this zero-day process, but if you say this is something that we didn't know before, it's not a mistake. But if you really want to understand this term, then you have these three sections. The biggest problem is when the zero-day vulnerability is published. Why? Because this is the moment when anybody learn from the internet, from the news, how to penetrate to a specific facility. So as long as it was secret and nobody knew about it, there was no major problem. But when it's published, this is the moment where you have to act very, very fast in order to block the attacker who is exploiting the zero-day vulnerability. The next topic that I would like to talk about is the APT. Why? Because you hear very often that a certain power company was attacked 1,000 times, is attacked 1,000, 10,000, 100,000 times in a month or in a year, but these are not a focused attack. We need to worry mainly about the APT type attack because when we speak about APT, we are dealing with an attacker who has a motivation, who has the resource, who has the time, and he got a simple instruction. Take any resources that you want and conduct that attack. You must be successful. So this is not a sporadic attack. This is not an attacker who is just looking to attack anyone. This is the focused, targeted attack to a specific organization, a specific factory, or a building, or a power plant, or a water utility, and this is the moment when you need to worry. If your organization is targeted by an APT attacker, you must assume the attacker will succeed. Very, very important. And furthermore, we will talk about defense, but I only can say that in order to protect your organization, you must assume that your organization might be a target for an APT type attack. Let's talk about another major problem, is the backdoor. What is a backdoor? In many cases, we see situation that employees or service personnel or anyone who want to create an attack is connecting a backdoor modem to your system. You may not know about it. For example, you have a major problem, and then you connect a modem so the service person can instantly connect to the system remotely. And why? Because this is a major problem. And this is fine. As long as you supervise that connection, this is fine. But what happens if you not disconnect that modem? You leave it connected for a day or 2 or a month. And the attacker who is scanning the system, many systems, he will find out that there is a backdoor directly to the industrial control system, and during the weekend, during the night, when you are not worried about the system because you don't know there is a backdoor, the attacker will penetrate to the system and they might create an attack. So we need to be very, very careful when we connect a modem. First of all, you must have authorization before you connect the modem, and finally disconnect it. There are many documents written about remote access, how to allow secure remote access. most important instruction is that you must disconnect it immediately after the service is completed. I would like to show you one more very popular chart. Actually, this chart is shown in the standard ISA IEC 62443, and it's talking about the risk. How do you estimate or how do you calculate the risk? So basically, we are taking two factors. One factor is the probability, the likelihood that someone might attack your system. And the second is the impact. What is the impact? An impact can be an outage, a short outage, a longer outage, a damage to equipment, or an impact can be an explosion. So if you are on the left side where all the colors are green, you don't need to worry very much. But if there is a high impact and high probability that your plant, it can be a manufacturing, it can be a power plant, it can be a oil and gas refinery, might go under attack, then you really need to be prepared for that. I would like to talk a few more minutes about the true cost of the cyber breach. What happens when an organization after organization get attacked? First of all, you have a lot of administration costs because you need to do internal inspection. What happened? You have legal costs. You need to involve regulations and do liability assessment. You have the lost revenue because your plant is not producing. Then you have many types of post-incident costs, investigators, forensics, repair the problem. And all these, I would say, cost a lot of money and manpower. But don't forget that there is a personal involvement as well. Why? Because in the IEC 27001, 2003, section 5, paragraph 1, it's clearly written that top management is responsible for cyber security. What does it mean? That if a cyber attack occurs on you, the organization, the CIO, the CISO, all must be worried. So this is something to remember. When we speak about the defense, on the right side you see the famous PPT triad. What is a PPT triad? On the top you have people. People must be trained. People must be aware of what can happen. Organizations must have policies and procedures. And finally, technologies must be used in order to protect your system. How we are protecting the system? There is no silver bullet. There is no specific solution that you say, oh, I buy this software, I buy this defense, I buy this firewall, and I'm fine. Not at all. There is no one cyber defense measure which can be absolutely effective. So you need to have a layered defense. You need to worry about the perimeter security, where you have the firewall, you have the network access control. You need to worry about the endpoints, all the computers, all the programmable logic controllers, all devices must be protected. You need to worry about the network communication. If you are using wireless, you are using encrypted communication, you are authenticating the connecting entities and so on. And finally, and most important, you need to worry about the process. And you see why the process is in the center, because this is where the risk might happen. A temperature may increase, a pressure might increase, an RTU or PLC may not function properly. So this is the way how you defend, and let's go slightly to more details. According to ISA IEC 62443, which I already mentioned, most important action for defending your system is zoning and segregation. Zoning and segregation means that you need to identify the different sections in your organization. You need to isolate them, either physically isolate them or logically isolate them using wide range of firewalls and other type of appliances which I'm going to explain. But most important, segregation and zoning. Why? Because if an attack will happen to one zone, you want to prevent lateral movement of the attacker from the point where he entered to the system to the point, to the zone where attacks might happen. One of the important defense measures is the DMZ, a demilitarized zone, and you can see the architecture of the DMZ. It always have a pair of firewalls, and the idea is that no information, no data can go from the left side to the right side, from the corporate network to the industrial OT network directly. It must go through the demilitarized zone where we can do deep packet inspection, we can change the protocols, we can do many things to inspect the information before it's forwarded to the other side. And you can see that it's working in both directions. So DMZ is a very good solution for protecting the OT network from an external attack. The second measure is the unidirectional security gateway, a diode which assures that data can go only in one direction. The typical direction of that data is from the industrial zone to the IT zone, and then it can be exported to a management or buyers or maintenance people, but you do not allow two-way communication. What does it mean? It means that attacker cannot penetrate to the industrial network. Why? Because the unidirectional security gateway is the only protection which is not software-based but hardware-based. There is only one transmitter, fiber optic transmitter, and only one receiver, so data can flow only from the left to the right, but it can never flow from the right to the left unless there is a special reason, and then for maintenance or software update, then somebody may rotate the diode for a very short time. The second cyber defense measure is what we call anomaly condition detection. Anomaly condition detection we are using when we cannot define what we are looking for. For example, we are worried about a zero-day attack, something that we cannot define, but we know that that temperature or that pressure or that vibration have a baseline. We know how it is working, and if there is a deviation from that baseline, then of course we can detect it. Usually we are using products like intrusion detection systems, IDS, which can perform anomaly behavior detection. Sometimes we are using network IDS, sometimes we are using host-based IDS, depending on the architecture of the system. In In larger organization, we often see a solution which is called Security Information and Event Management. We call it SIEM. Some people call it SIEM SOC. SOC is the Security Operations Center, but in reality, these are two entities. And the role of the SIEM is like an intelligent supervisor. Data and logs are being forwarded from all the appliances in your organization to the SIEM. The SIEM is performing intelligent analysis, detecting anomaly conditions, detecting any type of unusual behavior of the system, and it can issue an alert to the operator, but also information can be forwarded to the SOC. The SOC can be a on-premise SOC, or it can be an outsourced SOC. SOC is the room where we have many analysts. They don't really understand the industrial process, so the SIEM must create the alerts in a way that the SOC people will understand it. So this is in a larger organization, you will have a SIEM or you have a SOC. If you have an organization which have many facilities, like a power company or oil company, which have many facilities in different locations, probably each location will have a SIEM, and all will be sending the information and the alerts to the SOC. Another topic I would like to talk about is the industrial Internet of Things. The Internet of Things is a kind of new solution. Of course, obviously it's not new because we had it many years ago, but now you can see that the idea of the industrial IoT is expanding the industrial control system with many more sensors which are being forwarded to a intelligent service provider. It can be a manufacturer of the pump or the manufacturer of the turbine. But what I'm showing here, that forwarding that information must be done in a secure way, because the fact that you are adding more sensors and you are collecting more information, you must be sure the attacker cannot penetrate and manipulate that information, and by that he can confuse the operator and something bad can happen. So important to know that there's a difference between IoT, which is used in commercial type applications, and industrial IoT, which is used in together with industrial control systems. Sometimes, as we see on the right side, it's fully integrated with the control system. On the left side, we can see an independently operating IIoT, which is using internet or cellular communication to the service provider. I would like to show one more defense measure. Time is short, so we have a few minutes to complete it. We are talking here about upgrading the industrial control system with additional sensors or a stronger PLC, which is performing more detailed or more granular analysis than a typical SCADA system is doing. So what we can do by adding that solution, we can improve the probability of detecting malfunctions before a damage can happen. I would like to talk about the vulnerability assessment. Every organization must perform vulnerability assessment. It can be done once a year. It can be done twice a year. It must involve management. You need to define what you want to do. what kind of vulnerabilities you want to detect. And finally, when you are detecting these vulnerabilities, you need to have a plan how you are going to improve the situation, how you are going to mitigate a specific vulnerability. It's the process. It requires all the stakeholders in your organization, and it must be done properly. Finally, most important, in order to protect your organization, you need to be ready. You need to work around the year, every day, every week. You need to invest time. You need to know what are the critical zones where damage might happen. What kind of damage can happen? What can be the impact? You need to prepare yourself and train your team about how you are going to shut down the industrial processes if something is happening. If you are not prepared for that, your team will not know how to do it right. And be ready for escalation of the situation. If you detect something, the management must know about it, and you need to take immediate actions in order to protect your organization. I would like to talk a little bit about the standards. There are plenty of standards for protecting your industrial control system. The most famous one is the NIST, National Institute of Standards and Technology, the NIST 882, 853. Then you have the ISA in the bottom, ICS 62443 standard, which is the most detailed standard that people can use in order to perform assessment on the organization. Power utilities, they like to use the NERC SIP, specifically done for large electric companies. Then, of course, we have the ISO 27001 2013, which is dealing with how organization should be protected and more. So there are plenty of standards. I'm not saying that someone can use all of them, but you need to decide which is most appropriate for your organization and assign the team for studying it, learning it, and practicing the operation. I would like to complete this presentation with some very important messages. Put your security goals into your specification. This is very important because in the past, we didn't do that. Cybersecurity was not defined when organizations purchased the industrial control system. You need to deal with vendors who take cybersecurity seriously. You need to ask the vendor, do you comply with ISA 62443? That's very important. Do not compromise on the requirement. If there is a requirement, try to make sure that the system design, the vendors of components, the integrators, the maintenance organizations, all knows how to comply with cybersecurity requirements. And finally, always be ready for tomorrow's challenges. And I'm not shy to say, always be ready for tomorrow's surprises, because things can happen and you need to be ready. So thank you for participating at this presentation. And I'm now ready to accept questions. All the questions which we will have time will be answered. If there will be some questions after the event, you would like to send me personally specific questions, feel free doing so. So again, thank you very much, and I'm waiting for the questions.
Daniel Ehrenreich. É um prazer receber você dentro do Cybersecurity Summit. Hoje ele vai estar falando sobre treinamentos e funções da parte de escada. Como é importante ter uma abordagem e uma abordagem coordenada para essa cibersegurança dentro do aspecto industrial. Obrigado, Daniel. É com você.
Thank you, Rafael, for inviting me to this conference in Brazil, Cybersecurity Summit Brazil 2020. My presentation is going to focus on coordinated